This is a demonstration of logging, reading, and storing differential pressure data from the flow loop. The Foxborough differential pressure transducer sends in current signals for the NI data logger to read and store. Basic wire connections to begin with. The gray wire comes out of the pressure transducer, which has two separate wires. The green wire is positive and the white is common, which actually sends in current pulses, which are read by the data logger. The data logger itself needs a 12 volt DC supply, which is coming out of there. That's the power source. The positive of the power supply goes to the positive of the transducer positive wire, and the common or negative or ground goes to COM port over here. You can use any one of those 9 channels to get current feed in from the differential pressure transducer. I'm using port 0 over here, but you can use any one of those. So once you have those basic connections done, you can open up the code in LabVIEW, which is, for me, it's called Austin Edits. It should be shared on Drive. You can rename it later on. So things you can modify over here. This is the dashboard for the code. The physical channel, the port that you're actually using, from 0 through 7, the 8 ports that you can use. I'm using 0, so I'm going to select that. And once that's done, you don't really have to change the maximum and minimum current. They should be set to 20 milliamps and 0 by default. What you can change is sample rates. Say you want to read one data point or one differential pressure data point per second. You go one sample rate and one sample per loop, and you can run the code as is from over here. And once you do that, let me change the scale here. You can change the amplitude scale to whatever you want it to be. So I'm gonna do that. Okay, so there you go. Now it's running. It's showing 0, which it should be showing the differential pressure. And if you do want to log it and store it for analysis later on, you go down to logging settings and you move to log and read, specify a file name, and run the code again, and you should be able to save it as a TDMS file. You can open the TDMS file in Excel. You need an extension which you can download from the NI website. It's pretty straightforward. Once you have that extension, you can open that up in Excel and analyze or look at the data that you acquired from your tests. And that's about it.